several deconvolution methods, explaining step by step which ones exist, and yeah, actually, I like just the ones which actually do a transformation, which realize that bulk is not the same as pseudobulk, so they convert the pseudobulk and the bulk data to make it look more pseudobulk-like, so that the deconvolution algorithm can predict it better, because of course the ground truth reference is from pseudobulk. The way it works is, I think that's a very good representation. You first have the tissue, then you do bulk RNA sequencing and single cell RNA sequencing, and then yeah, you have like n individual, like you ideally this is like same from the same tube or something, and then you have like n individuals. You have m genes, which are kind of they have more, like it's a different number, but you just take the intersection. Then then you take the cell type labels, and then the reference profile, and you from like single cell you then calculate the reference profile, which is just like the cell types or cell states, and then as the columns, and then as the rows you have the proportion of the gene expression. So for like and then you also calculate the observed proportion per sample, and then here's kind of where you get like more into synthetic data, because what you do then is you ignore this, you don't actually bulk this, you take this and then multiply it by this, and then you can see here that's a convoluted single cell, and then for bulk of course you don't need to really do something, but yeah, then the way you transform, and that's I guess where it gets interesting, or like what I will now go through. So this is differing a little bit between bisque and squid, and so squid basically what they do is they start with this like synthetic pseudobulk, and then they take this as well as the bulk, and like independently get like the z-score, like, and now we're just talking on like per gene level, so it's yeah, so I think we kind of went off. Then so basically you have the transform thing, which I calculated. Really all it is kind of just plugging this in here, and this you then learn, and for the semi like supervised, the only change is that instead, like, this term is just constantly set to 1 like the square root of 1 divided by n plus 1, I think. Yeah. Yes, n plus 1, and for squid, and then you predict like just with these squares and everything. And the squid thing is the only thing which they do differently, is they set like c constantly to l minus 1 divided by l plus 1, except that everything is the same. They have the like no leave one out. They just like, I guess, leave one out. They really don't learn anything. The only reason this is because they basically want to test in, I guess, the best case scenario, what values would you get for this if you just like leave one sample out, and there's nothing, no training or anything else going on, and then you have the dampened weighted least squares, which I should probably also explain. Okay, and yeah, basically the dampened weight least squares just means you apply like least squares and then you do it weighted, so you like just see whatever like minimizes the error further if you put way specific genes more or less, and you do this like over some iteration until this converges.